Alright, hey guys, this is your lovely review video for our Polygons quiz. As you see on your screen, these are the learning targets you're responsible for. Most of them are actually really easy to handle. The first one, two, three, four, five, the first five of them are basically memorization issues of knowing what is what. Alright, so the first one is knowing the definition of a polygon. You have to know there's actually 5 criteria. You need to know those criteria. Identifying polygons by number of sides. That's just knowing quadrilateral, hexagon, heptagon, all of those. Classifying as concave or convex. Again, that's just knowing that definition. Classifying as regular or irregular. That's just knowing what regular and irregular mean. That's not doing the problems. And then this fifth one, using the angles interior, that should say interior, by the way, interior angle sum formula to determine the angle sum. That is simply using the formula straight as it is. None of those deal with any problem solving. The next two are probably the harder ones, using the interior angle sum formula in problems. So, if I say, can a regular polygon have an interior angle sum of 5,000? Then you have to use that formula in it. And then solving problems involving regular polygons, that's, using the perimeter, all those kinds of things. The drawing and identifying exterior angles, I don't think is too difficult. I think we got that down at this point. And then again, another problem solving one using the exterior angle sum in problems. So we're going to go through this. We're not going to take too long. We had a practice quiz today that looks kind of like tomorrow's test, quiz. We've been working on it for a couple weeks, so it shouldn't need too much review. Quick note, it knows the definition of polygon. So, things that a polygon has to be, it has to be closed. So if we draw an example of that, let me change my color here. I'll make it bright yellow. Why not? Okay. Closed means all of my corners have to connect. Now, it does not matter if it's concave, right? I could make this concave just like that, but all of my corners close. Open would be, well, that wasn't meant to be open. Something like this, right? Where all the corners do not connect. Two-dimensional is pretty straightforward. It cannot be a three-dimensional shape. I don't have any things to draw three-dimensional shapes on here. But two-dimensional just means flat. So not cube, not cylinder, or anything like that. Straight sides. You cannot have any sides that curve. A circle. Let me draw that in a better color so y'all can see it. A circle or an oval is not a polygon. It does not have straight sides. No overlapping sides. An example of that's when we had like a star where the sides cross. They can only connect at their endpoints. They can't cross or intersect like this. And at least 3 sides, best example of that is an angle. An angle, other than the fact that it's open, it can't close. Without 3 sides, it can't be closed. So they have to have at least 3 sides. Next learning target is just a memorization one. Can you classify by the number of sides? Here is your list. You should have this in your notes. It starts with 3 sides, so triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. And remember the ones that don't have names? We simply put the number of sides dash gon. So an 11-sided figure is an 11gon. And we have dodecagon, and then 13gon, 14gon, etc. 15gon, 27gon. That's all that is that simply can you look at a shape or can you look at the number of sides and know what its name is. Nothing else to that. Classifying polygons as concave or convex, I will either ask you to draw it. So I may say, draw an example of a concave polygon. So you'd have to draw something that caves in. Right? The official definition is that when I connect corners, if I were to go to connect all of these corners, that it's going to cross somewhere outside. I cannot cross outside. See how I connected the corners with that yellow strip? That makes it concave, the fact that the diagonal goes outside of the box. I may ask you to identify. I may say, look at all of these shapes. Tell me which ones are concave and convex. Easiest way to do it, if you can't see it right away, if looking in your head doesn't work, simply go through and connect all of your corners, right? If I connect all these corners, even right there, I've got one that goes outside. That tells me that this is concave. Classifying as regular or irregular. Again, nice and easy. Here's the hard part to it. My question to you is this a regular pentagon? And you can't just say, yes, it is. It looks regular. Remember, regular means equal angular, so all angles are equal, and equilateral, so all sides are equal. This looks regular, but guess what? It is not. We don't know if it's regular until I start doing this, until I mark all these sides as congruent to each other. Now, keep an eye out. You cannot just have markings, because what's wrong with the markings that I just put on there? Yeah, it's saying that this bottom one, the one with the 2, is a different length than all the rest of them, and we can't have that, all right? So with the markings, they all have to be the same. The angles also need to be marked, so you're going to see those, well, sort of. It's very hard to draw with the mouse, I hope you guys know that. You're going to see curves on all the angles, all right? Just like with the lines, if I had 2 sets of curves, that's telling me that that angle is different than all the others, all right? So they all need to have the exact same markings. So they would all look like this. That now is a regular polygon. Equal sides, equal angles. All right, the last fairly easy one simply says, can you use this formula to determine the angle sum? All right, you got to remember the difference between the interior angle sum and the exterior angle sum. Okay, you have to know that. N minus 2 times 180 is the sum of interior angles. Exterior angles add to 360. Doesn't matter the number of sides. In this case, for the interior angles, the number of sides at n matters. So if I simply said, find the interior angle sum of a 27-gon. You do not have to draw this. Guys, I got lots of questions all day today. Oh my gosh, I have to draw that? No, you don't have to draw it. I would say draw it if I wanted to draw it. If all I want you to do is find the interior angle sum, you're just going to plug into your formula. So 27 minus 2 times 180, and you would figure out what that equals to. You will get calculators tomorrow, so don't stress about that. You don't have to do this on paper, even though I think you could. It's not that hard to do on paper. You're going to get 4,500 total is going to be your interior angle sum. So there's your lovely answer. That's all this learning target is. It's not difficult. The key is make sure you know that formula. You got to know your formula. All right, the next couple, those are the more difficult ones. Let me pull up a couple examples here from your quiz. From your practice quiz, not your quiz. All right, so both of these here are problems dealing with regular polygons. The key to remembering with regular polygons is regular means that we can divide, all right? So for instance, number 14, I could say in a regular pentagon, all right? So let me copy this picture and put it back here where I can actually write stuff on it. Well, that's a really big picture though. Let me shrink that up a little bit. All right, so it's a regular pentagon. So first thing I can do is I can say, well, how much do all of those interior angles sum up to? Some of you have this memorized by now, some of you don't, but it's just number of sides. So 5 minus 2 times 180 does in fact give you 540. So that tells me all of those interior angles, the 5x plus 8, the 5x plus 8, the 6x minus 12, the 108 degrees, and the 4x plus 28, all of those add up to 540. Okay? 2 ways you can go about doing this. You can simply write out the long way. So you do, just going around the circle, 5x plus 8 plus 5x plus 8 plus 6x minus 12 plus 108 plus 4x plus 28 equals 540. You would solve for x, and then again, the key is all of those angles have to be the same. So once you solve for x, all right, so you would combine your like terms and all of that stuff. In this case, x equals 20. You then have to go and plug that 20 back in and make sure all of those angles are exactly the same. So I'm going to take that 20 and I'm going to plug it back in to here, and there, and that one over there. And as soon as I find some that are not equal, that are not congruent, even to this 108, if I plug into the 6x minus 12 and I get 100, I can stop right there because 108 and 100 are not congruent. They have to be equal. Okay? The same thing works with perimeter as well. But what I was saying about the fact that it's regular and you're allowed to divide, the other way you can go about doing this one is if I take 540 and I divide it by 5, because there are 5 interior angles, this will tell me exactly how much each one should be. In this case, it is 108 degrees. I could not do this if this were not regular. I can only do it because I'm trying to figure out if it is regular, right? So then I would check, is 4x plus 28 equal to 108? It's kind of like a question. And when I solve, I would check what I get for x. Okay? So you check all your sets of angles. So you check 4x plus 28. Is that it? Is 5x plus 8 equal to 108? So these are kind of like questions you're asking yourself. When you go through and solve for x, you have to make sure you get the same value on all of these. So you do that for all your angles. Okay? But again, this thing here in red, let me box that in for you so you can see what I'm talking about even better. Okay, let me fix that box because that is not what I meant to do. No fill. There we go. Alright. This right here, the fact that I was able to divide by 5 is only because I'm looking at regular. You cannot do that if it is not regular because the angles are not all the same. Alright, drawing exterior angles in either direction. I think we got this pretty well. I will specify on the quiz tomorrow which direction to go in, but to be honest, if all you do is mix up your directions, you'll get almost full credit. Okay? The idea is that you start at one corner, right? If I'm going clockwise, easiest if you start at a bottom left, honestly, and kind of go up. And you just stretch out each side. You use your protractor because you want these to be nice and straight, but you just start at the corner, trace along the side, and then stretch out. So these are all of the clockwise exterior angles. Counterclockwise just means you're going the other way, as if I was to follow the clock around backwards. Counterclockwise, if it's starting the corner, stretching them out. You've got to use a protractor. These have to be straight. Please take your time and make them nice and neat. Okay? That's all there is to that. Nope, wrong direction. There we go. Alright. I believe this is our last learning target we need to look at. So, using the exterior angle sum in problems. There are two key things here. Alright? All exterior angles have to add up to 360, and each exterior angle is supplementary with its interior angle. Okay? So, for instance, let's look at this one. Can a regular polygon have each interior angle measure 154 degrees? That is the longest think. There we go. It takes forever to think about what it's pasting in. Alright. So, there's several ways to go about this one, but the easiest one is to use the exterior angle. I know the problem specifically says interior. But what do we know about each exterior and interior pair? Yeah, they're supplementary. So take 180 minus the 154, I get 26 degrees. And what that is the measure of each exterior angle. Right? So if I know the measure of each exterior angle, right? So that's using the exterior angle part. Because this is asking about regular, since we just talked about regular, regular says check with a division, all right? It's saying, can we take the 360 degrees, the total outside degrees of a polygon, and divide it into chunks that are 26 degrees each? Can we do that? All right? When we do that, when I check that division, I think I get a decimal. Yeah, I get 13.8. And what that's saying is that this polygon has 13.8 exterior angles. And we definitely, I hope you guys realize, cannot have 0.8 of an exterior angle. Angles are one of those things, they're whole or not whole. You know, there's certain things I can't have decimals of. It just doesn't make sense. So this is going to be a no. No. You cannot have partial angles, right? Remember, whenever I ask you a yes or no question, you have to provide us an explanation. Explanation. If you just give me yes or no, it will be wrong. You will miss a lot of points without that explanation, okay? So that's your quiz. Sorry it took 15 minutes, but you know, you got through all of it together just fine. Have a good night.